ಹೇಳಿದ್ರೆ ಆಮೇಲೆ ಈಗ ಮಾಡಿ ಏನು ಮಾಡಿದ್ದಾರೆ ಅಂತ ಅದಾಗಲಿ ಅವ್ರಿಗೆ ಗೊತ್ತಿಲ್ಲ ಯೂಟ್ಯೂಬ್ ಸಿಮ್ಮೇಜ್ ಮಾಡ್ಬಿಟ್ಟಿದ್ದೀನಿ. ಇಬ್ಬರು ಇದ್ದೀರಾ ಒಬ್ರು ಇದ್ದೀರಿ?
Thank you, sir. Good evening, everyone. I am Ramesh Krishna, research scholar of this department. I am here for a presentation on proposed research work for my research, which is on design and development of VLF receiver for ionospheric studies. And my research guide is Dr. Kamsali Nagaraj. Let us see what is ionosphere. Ionosphere is one of the layers of atmosphere where ions are concentrated in this layer. It ranges from 50 kilometers to the 1,000 kilometers of height from the surface of Earth. This region contains all the charged particles of the Earth's atmosphere, and it acts as a boundary between the Earth's atmosphere and the space. Many low Earth orbit satellites are placed in the region of 100 kilometers to 2,000 kilometers, and this region is highly influenced by weather and space weather phenomena. This region is divided into 4 layers, that is D, E, and F layers. In daytime, the F layer is divided into F1 and F2 layers. The radio signals are highly perturbed in this region due to the interaction of ions and the radio signals. The radio waves of frequencies 3 to 30 kilohertz, which are transmitted from the transmitters of the Earth's surface, gets deflected in the D layer, and it travels in the Earth and ionospheric waveguide. The VLF radio waves get disturbed or perturbed due to the presence of electrons in the ionosphere and alters the characteristics of the VLF signals. The main objectives of this research is to develop the VLF receiver and antenna for studying the lower ionospheric perturbations, to understand the effects of solar flares and coronal mass ejections, galactic cosmic rays on the ionosphere layer. The study on ionospheric perturbations over low latitude region is also a main objective of this research. We study the perturbations through the characterization of VLF radio signal and the changes which occurs on the VLF signals due to the seismic and solar eclipse. There is also many atmospheric anomalies occurring at the atmosphere. Through this remote sensing VLF technique, we can try to address those anomalies also. methodology. When solar flares are ejected from the sun, it emits radiation in the region of UV and X-rays, which takes 500 seconds to reach the surface of the Earth. Due to the radiation of due to the solar radiation, the density of low latitude ionospheric layers increases along the day side. This enhancement can be used to study or identify the type of solar flares which has caused that increase in the ionospheric layers by monitoring the signal intensity of the VLF signal. Yeah. The disturbance or the perturbations on the signals due to the electrons present in the path of a signal between which is known as total electron content of the layer, and these electrons influences the radio waves which are traveling in the D layer of the ionosphere. When the radio waves are passing over the ionosphere, uh, due to the interaction of the signal, VLF signal and the electrons, there will be a velocity change, and there occurs a total delay of the radio signal, which can be determined by the frequency of the radio wave and the total electron content between the transmitter and the receiver. The radio waves with only certain frequencies can pass through the ionosphere, which is used for detection, and many other frequencies of low order radio waves will get reflected by the ionosphere, which are useful for monitoring the lower layer of ionosphere. The variations can be studied through the temporal and spatial variabilities of the radio waves, and the other uh, detection methods are global campaign method, regional campaign method, and single station observation. In global campaign method, the receivers are placed all over the globe to study the overall ionosphere, overall to study the global ionospheric uh, variations. In regional campaign method, the receivers are placed only in a particular region of interest. In single station observation, only a single receiver is placed over a particular place of interest, and different signals are different signals are received to that single station from the different directions. These are the VLF transmitters which are selected for the research work. The first one is in the USA, which operates at 24 kilohertz. The second one is at Australia, which operates at 19.8 kilohertz. The third one is in Hawaii, USA, which operates at 21.4 kilohertz. Um, Fourth one is the VLF transmitter, which is in India, which is the only nearest VLF transmitter to our station, which operates at 18.2 kilohertz. Fifth one is in the Japan, which operates at 22.2 kilohertz, and sixth one is in UK, which operates at 19.6 kilohertz. this is the geographical locations of the VLF transmitters uh, through from we can see the signals are transmitted from transmitter to receiver station. Sir, the proposed receiver station in instrumentation. This is the block diagram for the proposed VLF receiver, which has antenna, low noise amplifier, a mixer supported by local oscillator, intermediate frequency amplifier, and a filter. And the next comes the demodulator section, followed by ADC and the digital signal processing unit. The segment circuit is yet to be studied and has to be realized in the coming days. The basic principle for building a loop antenna is the electric and magnetic field of the radio waves. The antenna works when the plane of the antenna uh, plane of the antenna is perpendicular to the radio waves and does not operate when the uh, plane of the magnetic field is parallel. How we carry out the work, how we proceed. We first design the antenna, followed by designing of receiver and realization and testing of antenna and the receiver. Plan of action. First, we design and realize the antenna. After realization of antenna, it is subjected for testing under the laboratory conditions, and once it passes all the test, then it is tested with the real-time signals. If the antenna is not functioning with the laboratory conditions, it is again redesigned and subjected for all the checks for the parameters of the antenna, and again it is placed for real-time signals. For receiver circuit, first we design and realize the circuit. After realization of circuit, it is subjected for the testing at the laboratory level. If all the tests are passed, then it is integrated with antenna, and again it is tested under the laboratory condition, and after clearing all the parameters, it is tested with the real-time signals. Thank you.